Now let's prevent a solution here given this nice exponential equation, which is k minus 3 to power 4. This is equal to 6 to power 4. So what are the values of k? Now solution from here, we have that k subtract 3 raised to power 4. This is equal to 6 to power 4. Now the first step here, let's take 6 to power 4 on the left hand side so that we have k minus 3 raised to power 4 subtract 6 to power 4. This is equal to 0. We can express k minus 3 to power 4 as k subtract 3 raised to power 2, okay? All this raised to power 2 again, subtract 6 to power 2 raised to power 2. This is equal to 0. The next step here, you find that this is actually in the form of a squared minus b squared, which we can express as a plus b, okay? And then we have a minus b. Now from what you have here, a is equal to k minus 3 squared, and b here, this is equal to 6 to power 2. So in this case, we have that a plus b here, this is equal to k minus 3 squared plus 6 squared. This is equal to 0. That is the first, we can call this the first equation here. Then a minus b, this can be expressed as k minus 3 squared minus 6 to power 2. This is equal to 0. Let's call this equation 2. Now from here, we can deal with case 1 here, which is equation 1, which is k subtract 3 squared plus 6 squared. This is equal to 0. We have k minus 3 squared plus 6 squared. This is equal to 0, okay? This is case 1. Now, k minus 3 squared, this is in the form of a minus b squared, which we can express as a squared minus 2ab plus b squared. So applying this algebraic identity, we have that k minus 3 squared expressed as k squared subtract 6k plus 9, okay, plus 6 squared, which is 36. This is equal to 0. Now the next step here, we have k squared subtract 6k. Now here we have 9 plus 36, and this is actually equal to 45. This is equal to 0. Now this is a quadratic equation of the form ak squared plus bk plus c. This is equal to 0. Now from this quadratic equation, a is equal to 1, b is equal to -6, and c is equal to 45. So let's solve for the values of k in this quadratic equation by applying the quadratic formula as follows. Now here we have the quadratic equation here with a equal to 1, b equal to -6, and c equal to 45. So applying the quadratic formula here, we have that k1, k2, this is equal to -b plus or minus the square root of, this is b squared minus 4 times a times c, all this divided by 2 times a. Let's substitute the values of a, b, and c. Now here we have -6 plus or minus the square root of, that is b squared, which is -6 squared, subtract 4 times a, which is 1, times c, which is 45, all this divided by 2 times 1. The next step here, we have negative times -6. This is actually equal to 6, plus or minus. Now, -6 squared, this is 36, subtract 45 times 4, this is 180, all this divided by 2. The next step here, we have that 6 plus or minus, now the square root of 36 minus 180, this is -144 divided by 2. So that now from here, we have 6 plus or minus the square root of -144. This can be expressed as 144 times -1, all this divided by 2. Now the next phase here, we have 6 plus or minus the square root of 144, this is equal to 12. The square root of negative 1, this is I. All this divided by 2. The second step here, we can factor out 2 here. 2 is common here. So that now we'll have 3 plus or minus 6i divided by 2. So let's simplify here. So that now we'll have k1, k2. This is actually equal to 3 plus or minus 6i. So in this, we have k1 equal to 3 plus 6i, and k2, this is equal to 3 minus 6i. So these are the two complex roots here for case 1. So let's proceed to case 2. Let's proceed to solve case 2 as follows. Now for case 2 here, we have k minus 3 squared minus 6 squared, this is equal to 0. Now k minus 3 squared, this is in the form of a minus b squared, which you can express as a squared minus 2ab plus b squared. Now we have that k minus 3 squared minus 6 squared. We have that k minus 3 squared. This is in the form of a minus b squared, which you can express as a squared minus 2ab plus b squared. Applying this algebraic identity, we have that k minus 3 squared. This can be expressed as k squared minus 6k plus 9. All right. Now let's substitute this here. We have k squared, subtract 6k plus 9, subtract 36, this is equal to 0. The next step here, we'll have k squared minus 6k. Now 9 minus 36, this is minus 27, this is equal to 0. Now this is the quadratic equation with a equal to 1, b equal to negative 6, c equal to negative 27. Now, the next step here, let's apply the quadratic formula to solve for this quadratic equation. Now, we have that k3 and k4, this is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Let's substitute the values of a, b, and c so that now we have negative 6 plus or minus the square root of b squared, this is negative 6 squared minus 4 times a, which is 1, times c, which is negative 27. All this divided by 2 times 1. The next step here, we have negative times negative 6, this is actually 6 plus or minus. Now, we have the square root of negative 6 squared. This is equal to 36. Now, we have negative 4 times negative 27. And this is plus 108. Okay? All this divided by 2 times 1. Now, the next step here, we have 6 plus or minus the square root of 36 plus 108, and this is 144. All this divided by 2. Now here we have 6 plus or minus the square root of 144, this is 12, divided by 2. Now here we have 6 plus or minus the square root of 12 divided by 2. Now this is 6 plus or minus 12 divided by 2. So that means we have k3 equal to 6 plus 12 divided by 2. And this is actually equal to 18 divided by 2. And this is equal to 9. K3 is equal to 9. And we have that K4. This is 6 minus 12 divided by 2. 6 minus 12, this is equal to negative 6 divided by 2. And this is equal to negative 3. Now in this case, we have 4 solutions here. K1 is equal to 3 plus 6i K2, this is actually equal to 3, subtract 6 high, and then K3. K3 here, this is equal to 9, and then we have K4 equal to negative 3. So here we have 4 solutions here. We have 2 complex solutions and 2 real solutions. 2 real solutions. So thank you for watching. Kindly follow the steps, like this video and subscribe.